Brum brum, here's Mr. Pepperell on his new motorbike. Mr. Pepperell's very interested on how fast his new motorbike can go. So what Mr. Pepperell needs, if he's going to work it out, is a distance time graph. That's what he needs. So the first axes, there's our axes. Now, the first thing you need to do is label up your axes. On our x-axis, the one along the bottom, goes the thing that we can decide on. It's our independent variable. And in this case, we can decide how long I'm going to ride my bike for. So time, measured in seconds, goes along the bottom of my graph. On the other axis, the y-axis, goes my dependent variable. And it depends on how long I ride my bike for. So in this case, how far I get, or the distance, measured in meters, is my dependent variable up the side. Lovely. We also need to give our graph some values, so I'm just going to say that my time axis runs from 0 to 10 seconds, and for sake of ease I'm also going to say that my distance axis runs from 0 to 10 meters. So my graph's ready to go now. I'm ready to start my journey. I'm raring to go at the top there. So at the moment on my graph we can see that no time has passed, so I've got a time of 0. I haven't gone anywhere. My distance is also 0. But I'm going to start on my journey now. I've driven for 2 seconds. In those 2 seconds I've covered 1 meter. So on my graph that looks like that. I've got a distance of 1 meter in 2 seconds. So that's what my graph looks like. I'm a bit more comfortable with my bike now, so I'm going to start riding a bit faster. That's enough for now. So I went a bit faster that time, so I went like that. The slope of the line shows us the speed. It doesn't tell us the value, but it shows us relatively how fast I was going. Now after that amount of time I decided to stop on my bike and sit still. Okay, let's get that out of the way. Sit still on my bike. Of course time was still ticking by, but I wasn't going anywhere. So my graph continued, time ticked by, but my distance value didn't change. It just kept going. It didn't mean to change, then my finger slipped. Okay, so that's what happened there. Eventually I decided, it's time to go home. Drive all the way home again. So my graph returns back to where I started. Okay, so there's my distance time graph. But what is that actually useful for now? Well, what it's useful for is working out how fast I was going at each stage. If we take this first section of the graph here, for example, we can see that in 2 seconds I covered a meter. Well, I said before that the slope of the graph shows us how fast I was going, and the slope on a distance time graph represents the speed. So we can actually work out the speed by dividing the distance I travelled in meters by the time it took me to travel it in seconds. So my distance travelled was 1 meter. It took me 2 seconds to travel that distance, so 1 divided by 2 is 0.5. What's my units? Well, I've divided meters by seconds. My units are meters per second. My speed during that first section of my graph was 0.5 meters per second. And again, we can do exactly the same thing on the next section of the graph, or any section of the graph for that matter. How far did I travel during this time? Well, 1, 2, 3, 4 meters, say, and it took me a total of 1, 2, 3 seconds to do it. 4 divided by 3 is 1.33 recurring, and I've divided meters by seconds, so that's my answer, 1.33 meters per second. That was my speed there. We can even do that for the bit of the graph where I was sat still. This section of the graph here. What was my change in distance during that time? Well, nothing. But how long did it take me to do it? 1, 2, 3, 4 seconds. But 0 divided by 4 is still 0 meters per second. So, just by using our distance time graph, I can work out how fast I was travelling at any point during my journey, because speed measured in meters per second is equal to distance travelled in meters divided by time taken in seconds. Lovely stuff.